Okay, thank you very much for listening to the second video. Now we move to the next video, and in the next video we are going to continue discussing about the spectral algorithm, which was initially proposed by Lacroix, Reiden, and Martinez. And then what next is maybe we can talk about some of its properties possibly. So what I have here is that the way the DF-Sane algorithm initialize, or the way it operates. So what I have here is that maybe given an initial iterate, so given an initial iterate, maybe x naught, the DF-Sane algorithm. So I'll just copy what this text tt and put it here instead of typing it again. The DF-Sane algorithm uses the residual vector. The residual vector now is in mass mode, so I have to put plus or minus, which is \vm, then f of xk, in a systematic way, and generate a sequence of iterates. Now we have a sequence. We also need the curly bracket to come out. So if we are in mass mode, we put / curly bracket open and / curly bracket close. Then I put xk inside, and then then I wanted to put the equation in which this DF-Sane generate the algorithm. So the equation is sk plus 1 equals to xk plus or minus lambda k alpha k f of xk, okay, equals to 0 and 1. So maybe I wanted to also put equation begin, and put another equation begin equation. This time around also numbered equation. So the equation is xk plus 1. Since I have more than one character, I have to put them inside curly bracket. So it's equals to xk plus or minus, that is \pm. Then we have f of xk, correct. Then we have some space. Maybe I can use quad k equals to 0, 1, and so on. So I will just put \c dot. That is, the 3 dots will come out. So this is the equation in which then we have to maybe explain what are these terms. Okay, I forget to put lambda and alpha k inside. So there is lambda before that. After that, plus or minus, I have \lambda, lambda k, then \alpha k. So where then I have to put comma here. Then I have to go outside the equation environment. I said where I will start with which one comes first, maybe lambda, lambda k, where lambda k is what is lambda k? Lambda k is greater than 0 is a step length, and alpha k is a spectral coefficient. So lambda k greater than 0 is the step length, th, and \alpha k alpha k is the spectral coefficient generated by, then we have to also put an equation for it. Spectral coefficient generated by, then the way this spectral coefficient is generated is in the case of equation and then cases. So first of all, I have to begin an equation environment, then I also begin cases. So begin equation. Okay, sorry for the mistake, please. I have begin equation, yes, begin equation, then end equation. Then I'll put so begin equation, end equation, and then I'll have to put backslash alpha k is equal to, then alpha k is given, the definition of alpha k is given by in cases, so I have to also begin cases there, begin cases, and cases. Then the first case is alpha k equals to 1 if k is 0, so it's 1. Then I'll put and, that is to get, and then I'll just put it in text mode, the if, then I have to provide an unbreakable space if k is equals to 0, and then next line, then it is what? It is another definition of alpha k is norm of sk minus 1 all over inner product of yk sk if k is bigger than 0. So I have to do this. So proc norm of xk, and at the numerator we have norm of xk minus 1 sk minus 1 sk minus 1 k minus 1 norm of sk minus 1 squared, so that's power 2 there. Then in the denominator we have the inner product item backslash L angle, and the R angle will be the R closer. So L angle of what? Y k minus 1, comma, then let me put tilde to put a space, unbreakable space there, then x k minus 1, then backslash R angle, then I close the inner product R angle, then and to separate it, then what is it? That is if k is what? So backslash text, put if as a text. So if k is bigger than 0, strictly bigger than 0, since that we put k equals to 0, then this is k bigger than 0, k starting from 1, or if you like, you can put k equals to 1, 2, 3, and then you put c dot like this, k equals to 1, 2, because we don't have k that is fraction. All the k's we have in are integers, or let's say they are natural numbers, so it's better to put this c dot, sorry. So that is for the definition of of alpha k. But you see, inside the definition of alpha k, we have some terms that we put that in which one may need to know their definition. So we have to go to that is end of equation. We have to go back. We have to move to the end of equation and then put where. Maybe then there is sk that we put. There is no definition of sk, and there is yk also that we put. We need that definition. So where this sk minus 1 xk minus 1 will be equals to xk xk minus xk minus 1. So we close the dollar sign, and then yk also, yk minus 1 will be equals to yes, f of xk minus f of xk minus 1. So this is the definition of the two. So let us first of all compile to see, maybe it will possible we make some mistake in the syntax of that cases or whatever. So if we see the mistake, we can correct the mistake. Okay. So there is no mistake. So everything come out, as you can see. Xk plus 1 is that. Alpha k is that. You see it, everything is come out. So this is some, of course we have already mentioned how this DF-SANE, that is this algorithm, the algorithm presented by Lacroix, Martinez and Reiden, gives the type of alpha k. So our interest is just alpha k. We want to we want to modify it, because in the paper of Lacroix, Martinez and Reiden, they put some safeguard that will make this alpha k to be bounded above and below. But in our own case, we want to maybe we want to design this alpha k in such a way that it is already bounded and well defined, so that we can use it, and it's also positive. So inshallah, in the next video we will continue with the generating the slide. Thank you for listening.